Hello and welcome to my talk about observability. And first of all, a personal thanks to all of you coming here. I know I have pretty tough competition with Josh speaking over in the bigger hall, so I didn't even expect anyone to come. So this is already looking very good. So thanks for that. So within the next 50 minutes, I want to talk about various options and showing a few tools and technologies to observe your applications, mostly on the focus of Java applications in the area of Kubernetes. So this is not only about k9s and OpenTelemetry. This is just like the range or kind of tools that it would span from a entry level, let's say like CLI-based, API-based thing, to like distributed tracing and getting really to the root cause of potential problems. Who I am? This is me. Here are my social handles, if you want to follow or connect or whatever this is called on whatever platform. I work for a company called Novatech. We've actually have quite a few 3 speakers around here, so make sure to see my colleagues' talks. One has already given his lab, so there's still Carlos, who is giving his talk on Friday. And yeah, in this role, I'm working with a lot of clients, with a lot of students, with a lot of people in general that I try to pass on all the things that I think I understood around cloud-native technologies and cloud-native approaches for software engineering. As I just mentioned, students, I also teach at 2 universities in the area of distributed systems. And what I kind of try to do there is like distributed systems with that modern technologies. I mean, the cloud-native space is definitely a good fit for that. So I would call this is like a modern version of distributed systems with microservices, containers, and all the things around it. So yeah, in a nutshell, what this will be about today, I already said it. We're going to look at observability. How can we look into things in mostly Java, but not only Java, running on Kubernetes? And also some of the solutions are not only for Kubernetes, but definitely this is kind of the major context. So yeah, why did you come to this talk? I hope the problematic of like the need for observability is pretty clear. People that have worked with Kubernetes will probably find it very kind of complex in the beginning, so you got to learn quite a few things in order to understand what's going on in there. And of course, I want to show a couple of tools that may make your life easier in order to get an insight. What are the components doing in there? How they are being connected, and if everything is all right. So. Just a quick question. Who of you is already using or has experience with Kubernetes? So, okay. Yeah, I was kind of hoping for that because this 50 minutes would certainly not allow me to go over the entire aspects of this platform. We teach in classes for this as well, so this normally takes 3 days. This is why I'm going to break it down into a few pieces just to make sure we all on the kind of same page there. So on a very high level, I would consider Kubernetes as like a distributed container daemon to run various types of workloads. With various types, I mean various frameworks, various programming languages, polyglot environment, and having that all connected. Some things we're going to relate to later on is also the infrastructure level of Kubernetes, where it's like you have a cluster of things with multiple worker nodes where all the workload runs, and the control plane, basically where you have, as the name says, the control over the cluster. So yeah, now there's many things. If I talk about observability around Kubernetes, what may I be speaking of? I mean, people will most likely be interested in what their applications and workloads are doing, if everything is running fine and as expected. But also, in order to observe Kubernetes, you've got to be a bit familiar with the terminology and the various API objects that you're dealing with. So things like deployments, pods, services, and so on. So that already makes it quite a fairly complex monitoring or observability scenario. Then there is the API server as an important component I already mentioned on the control plane. This is basically where you can interact with the cluster and query information, what is going on. And this will also be one aspect of this talk. So yeah, this kind of sums it all up. These are the things we might want to look into today. And then not only about how are the workloads doing individually, but also, of course, from a connection perspective. I mean, who is basically talking to whom? How long does that take? What is like, how many requests do I have? And so on, just to figure out if things are going in the way which I wanted it to have. Now, this talk will not have like a clear recommendation or say, well, use this tooling and or that tooling as the best solution. It's more about giving an idea of what the categories of observability are there. I mean, in a way to say, how much do you want, what actually the things that you would want to see, what are your problems, and how deep do you need to go into it, and how much do you want to invest. And with invest, I also mean from a software engineering perspective. I mean, we're going to see solutions where we basically will not modify anything in the cluster or the applications and still see some things. On the other hand, there will be things where you have to change the code and rebuild the code and rebuild the container. So this is what I mean with overhead and investment, which will be a responsibility in your software engineering process. And I just want to give you a bit of an idea, what can you get out of the observability with a certain level of interaction. So, and we have lots of like flying altitudes where you can go in there. So starting from the node level, then there is the pod level. In the pod, there's the container, and in the container, there's the application. And additionally, there's also the API server. So what I'm trying to say is when you want to start observing, it's also questions where would you start and where do you have to start in order to get the things out that you really want to have. So this is the thing we're going to look at first because it's like the least intrusive thing. So you can just go there and query things. And with all of those things, I would also try to show where are the boundaries of a certain scope. I mean, what are the things that you can query from the API server or from a node level, and which are the things that you would not be able to get from that. The nodes is the thing we're going to look next. Then we're going to look at the application itself or the pod. This should probably be in a reverse order, but it doesn't matter. So it's just like various ways of getting to certain observability metrics. All right. And yeah, most likely you're not going to need all of them. This is also a thing. I mean, observability can be expensive from an overhead, from a maintenance kind of perspective. So I hope I can give you some guidance in that as well. Now, tools. Most people have probably seen this lovely page. This is the CNCF landscape that shows all the various toolings around the Kubernetes ecosystem. And there's one dedicated section down here for observability and analysis. So even there, you can find quite a few toolings. I won't have the time to go through all of them. And some of the toolings I will also show is not even in there, or maybe it will never be in there. So, but still, the point I'm trying to make, there is a lot, and there will be a lot of decisions involved in order to set up your observability infrastructure. Now let's start with this. Kubernetes API, as I said, reaching out to the API server. I mean, most people that use that or start using that is probably by the kubectl command line agent, where you can query information in a way of like get, describe. You can query logs of a certain component. You can execute into a container and start a shell or whatever. There's also the kubectl debug command I'm going to talk about in a second. This is basically where people start. Now, there are also tools that connect to this API server and basically provide the same thing in either a browser or, let's say, improved command line output. I've been working in this area for a bit, and when I started when I did this initial version of this talk, I was like pitching this technologies Octant, weaveworks Scope, and Lens, and additionally k9s as toolings in that space. Now, things have changed a little. So Octant was officially deprecated. weaveworks was unofficially deprecated, or I should say just less activity around that. The project is still there. Lens has kind of gone commercial. There is a free trial, and there is an open version of that. but still, there's a lot of action and transition in there. So I decided to look at some new things. The things that I just saw in the last weeks were Headlamp and Schooner as two tools. K9s has been around for open source all the time, and it stayed like that. So this is definitely one I certainly want to highlight in my portfolio. I'm not sure how this all work out time-wise. So I have a few screenshots here, and if we're good towards the end, I would also like to show a few things live. So this is basically what K9s looks like, or maybe I can show it just live now. This where you basically have a command line based, so I can stop it. So you just type K9s and then it starts, where you can have an overview of all the things coming in your cluster. You can also see if some things are not actually right. You get a high-level indicator. So this is something which you probably wouldn't see if you just go out there and say like kubectl get all namespaces. Then you can see that the limitation of this client. So you get a lot of things on your shell, and it's kind of hard to dig through that. So K9s would summarize those things a little in a nicer way. And the things you can do there is you can change a configuration, you can open up a shell in a certain container, do port forwarding. Technically speaking, all of the things that you normally do via the command line anyway, this one will just summarize it and make it a little bit faster. And there is no requirement for any web server or whatsoever. You can pretty much run this in every shell. Now, this was an old screenshot of Octant, similar thing. I mean, it still works. You can still use it. It's just not supported anymore, or it's not going to be continued. But you get like a categorization of all your various objects. So you have like pods and jobs and deployments all on the workloads. Similar thing for discovery and load balancing, where you get services and so on. In the end, you can just like use your mouse then and click through, and you got the same things in the browser where you can say, okay, I'm going to open up a shell here now, and it's fairly convenient. This is the thing how it looks in Lens, and technically speaking, there's a lot of overlap, and there's not one that stands out in a certain way. So whatever you want to do there. This is Headlamp. This is something as well I could show quickly live. Okay, this needs some kind of authentication. We're going to get to that. Just taking this token real quick. Put it in there. And then we're in. So again, here you have this kind of aggregation in the navigation where you can say, I'm going to browse the workloads. I got my pods here. Then if I basically pick one of those pods, let's check for an application. This is from the OpenTelemetry demo. You would get all the logs here right in your browser. You can also open up a shell right in the browser. So you're now basically in the container. So they're easy to install, they're easy to set up, and I think they have a big benefit for easy using that. All right, so Schooner is just the same thing in white, so to say. Different open source community, but doing same things. So yeah, I just go shout out to those people. I think what they're doing is pretty cool, and I want to like promote their work a little bit here. All right, so one other thing is that called kubectl debug. So from all the people that raised their hands before knowing Kubernetes, who has been using kubectl debug so far? Ha, I thought that. And that was like me a few weeks ago. So it's fairly new. It's only been added to the kubectl API. And what it basically does, you can run an additional container in the same namespace of an existing container. And with namespace, I don't mean the Kubernetes namespace, like the container namespace. That means you can add a lot of functionality to a component which might not be there in the first place. So for example, here, I have this distroless container. So this is like a Java application in a distroless container. Distroless means there is no Linux distribution underneath. So there are no things like a shell or other Linux commands that you could invoke from remote. So if I would say, okay, I'm here in my in this environment. If I pick whatever application pod. Let's, for example, take this one. And now I press shell, so it's going to open a shell for me. Now, if I go back to this distroless one, if I ever find it again, and do the same thing, nothing happens. I mean, there would be an error message that we're probably not going to see. So even if I try to do the same thing, so I just need that name. That's the one here. So if I do kubectl exec -it, this is the one. And then I want to say start a bash. It will tell me there is no bash, or maybe another shell. So basically all the things are not in that container. This kind of makes it pretty hard for me to debug it and get any closer information. Now there's this debug command, as I said, and I'm too lazy to type now. That's just where we have to, where I say, okay, I'm pointing it to this pod, and I'm using this image. This is like a container that I built, where I build all the various debug toolings in there. And then I have to say, I'm going to target this container in the pod. And then it's basically going to share the same namespace as this pod. And now I suddenly have a shell. So if I look in there, I'm now in that container. This is like still the Java process is the main container process. But all the functionality which is in my in my debug container is now available here as well. So yeah, I want to display all the possibilities just to show you. This is all the stuff that I put in there. It's a lot of network toolings and whatsoever. For example, one of my colleagues asked me recently if he would only have like htop in a container to monitor things. So I just installed htop in my debug container, and I can run that like within the same namespace as the pod now. So this can be a quite helpful thing to debug and trace your applications. All right, so this is just the same command written here in the slides. So to sum things up, I mean, and this debug thing, unfortunately, I have not seen in K9s and any of the other toolings yet. So this is still the only way I'm aware about it, is to run it from the command line. To sum things up, on the side of the Kubernetes API, the good thing is you can just go there and execute them. As long as you have your the required rights, same thing as your kubectl, you can query all the things and aggregate and summarize. It helps especially in the beginning. If people are new to Kubernetes, for like getting an understanding on what is all the categories of the objects in there and so on. And you can, on an application level, you can go up to logging, but it's always just focused on the individual components. So you get no network insights. You don't know, I mean, some containers could be running as a ghost. You would not see all those things. It's, as I said, just kubectl in a nicer form, so to say. Now, the next thing we're going to look at is going from the API server to like looking on the level of pods. The most common technology that uses that are service meshes. So yeah, we have this application in a container now, and now we're running this sidecar container, like an agent within the pod, to observe some metrics. And just to going back to that debug thing that I said before, this works different. Like the debug call really put the new container binaries into the namespace of the other one. This one basically runs two containers within one pod side by side. Now people might say, why would I think of observability when I talk about service meshes? And this is probably a fair statement, because observability was probably not the main thing people had in mind when they created service meshes in the first place. So it was intentionally made for getting better grip over your network activities in the cluster, and also basically to interfere with it. So to do things like canary rollouts, A/B deployments, ingress behavior, and also on the resilience side, things like rate limiting, circuit breaking, and so on. But there's this project Cilium, which we're going to talk about later a bit as well. They wanted to build their own service mesh, and they asked in the community, so what would be the most interesting things, or like the most required things that you would expect from a service mesh? And by big surprise, the number one thing people answered was actually observability. So people do use service meshes for that purpose. Now, who of you is familiar with service meshes? A few? Okay, so I'm gonna talk about that a little more then. I basically said before, an application in Kubernetes is running in a container, and the container is basically like wrapped again in a pod. Why does this exist, this construct, in that way? It's because you can technically put multiple containers into one pod. This may or may not make so much sense to put multiple application containers in one pod. I mean, basically, the underlying technical thing you need to be aware of is if you put multiple containers into one pod, they will share the same file system, and they're going to also share the same network, which is basically what is being exploited here, because all the network traffic that one part sees, the other one will see as well. So there's no need for using things like services and so on. They can connect directly, they share the same IP address, they share the same port range, and so on. Now, still, I would always recommend to put just one application container into a pod, because only then you can take the functionality of like scaling and routing and all the things Kubernetes can do for you. But what might make sense is actually to put like a monitoring agent or proxy component into such an application, because that means this proxy component will be able to intercept all the network traffic that is routed to the application. This doesn't make a whole lot of sense if you only put it into one, but it makes more sense if you put it into many pods, because then you're going to get more observability into the various network flows in your cluster. And finally, you can aggregate all those things and send it to like a central instance for bringing the information together. So people here speak normally of a data plane on the collection side and a control plane on the, let's say, management side of things. The good thing, and talking about observability here again, this is totally independent of whatever application types you run, because it's not actually touching the application container. It's just basically being added. So it's basically the same component being added all over in those pods. So this will basically trigger a restart of the pod, but nothing else. You don't have to rebuild your container. You don't have to change your application configuration and so on. So it's pretty independent of the framework, and also it's pretty easy to switch on and off. I mean, you can just, if you want to try it, put it in. If you don't like it, you're going to take it out again. So from that perspective, it's a pretty good thing. And as you have the control over the network now, you of course also have the network visibility. So this is a very simple sample where you can basically get visualized how is the flow of my traffic going between the various components. Is it encrypted? You also could say like the request rate and the failure rate and so on. This is the technology that is doing that is called Kiali, which sits on top of the Istio service mesh. Of course, it makes more sense if your applications get more complex. So this is a screenshot from the, for example, Spring Pet Cleaning application. Again, I mean, you can put it into any kind of your Kubernetes clusters or limit it down to namespaces to get this, this functionality. There's a but. I mean, it looks pretty nice, but there is a but to that. That's the overhead. Because as you have seen, we are injecting this kind of agent component into every single pod. The CNCF, like the hosting organization of all those technologies, has made a benchmark of how much overhead the Linkerd and Istio, which are the two most popular service mesh implementations, would actually generate. And yeah, on the one hand, you get the overhead because you need additional CPU and memory, but probably the more impactful thing is the network latency. Because if you before a service mesh, you would just connect from application A to application B. But now you could go from application A to the proxy, from the proxy to another proxy, and from proxy to application B. That, by the nature of things, will slow it down. I don't want to go into all these percentiles here, because that's always different anyway, depending on what your application looks like and so on. The only thing which I can say for sure, there will be an overhead. So play with it and try it first, and then see if this is basically worth the price paying for what you're going to get in the end. So yeah, as I said, it's going to extend Kubernetes for the thing that it can't do, traffic awareness and shaping. You're injecting the sidecar. You can change that configuration at runtime with no other changes, but you're not getting any application level metrics. We look at the watch. That's good. Well, so okay, I can also quickly jump into that one. So I have a demo set up with 2 different clusters here. So jumping into that console, this is, as I said, come on, internet. It hasn't been that slow, that fast today. So yeah, you get kind of an overview. These are the various namespaces in the cluster. And these are the 2 that I have instrumented with Istio. So this is the OpenTelemetry demo, and this is the Spring Pet Clinic. I don't know if this one has actually some load on. I mean, if there's no load, you will not be able to see anything, of course. So let's just change this one here. Yeah, so it's kind of empty because there's no traffic flowing. I can possibly change that. This is a super fancy new test tool called JMeter that does those things. And then in a minute or so, we should be able to see something. Now, going back to that OpenTelemetry one, there is some constant load on. And now I can say, yeah, this is the most important thing, do the traffic animation, because then things start to look really beautiful. You will see all those like little things flowing all around. But in the end, you get an insight of what the traffic is like. So there's a load generator that connects to the front end. Then everything is flowing to the very API endpoints. And then you can say, well, I would like to see the response time. And then you would see the response times on these little arrows. Or I want to see the throughput or the traffic distribution and so on. And then you can see, like, of course, if you have an API gateway, you might want to know who are the services which are actually being invoked and where does the traffic go and so on. This is all the things that you can now do with that because, yeah, you have the network insights from all those little agents that run in your individual pods. All right, so where's my presentation? Here. I mentioned this project Cilium before. This one, the company behind that, they are like the main contributors to this technology called eBPF. Who has heard of eBPF? Also a few? Okay. In the first place, eBPF is probably not something you would think of as a monitoring tool. It's actually, it stands for Extended Berkeley Packet Filter. So it does not sound very much like monitoring there. But the packet filter kind of implies this, we are talking about network packages here. So we're going to go on the node level of things now. So stepping away from pods or API server. And the way that works, this is a high-level diagram of the Linux environment. So you have a kernel space and the user space. And I'm not a Linux kernel guy, so I wouldn't be able to explain you all those things. But the way it normally works is if you want to get low-level metrics, you got to go into the kernel space. But the kernel, of course, would normally not allow you to run any kind of custom code in the kernel. So eBPF kind of provides a sandbox mechanism where you can inject your custom code into the kernel, and it runs in a way that it cannot do any kind of harm within the kernel space. So on a certain level, you could imagine it like JavaScript in a HTML page. It can do all the things in there, but it cannot break out. Similar things happen here. So kernel events can be queried and observed. And of course, network events are also kernel events. So with that one, you go down very deep in your stack and query the information right from there. And then you can send it to the user space for further processing. So like of course, in the kernel, you can't write all kinds of sandboxed codes. This has got to be some low-level assembler or C or whatever stuff, things I don't really know. But once you get the metrics, you can process them further here in the user space and do basically a similar approach as we did with service meshes before. So we're going back to that Kubernetes nodes now. So this is a Kubernetes worker node where it runs all our containers. It has a container daemon and the Kubernetes objects, but it also has an operating system. And this operating system is very often a Linux operating system. And eBPF was written for that. So technically speaking, you can run now your eBPF code on your low level of your Kubernetes worker nodes and query all the network metrics from right there. So if we go back to that data plane, control plane idea, now you have the data plane not in the pods, but you have the data plane on the nodes. So you have individual kind of monitoring components. You should have basically one for every node. And then with that, you're going to get all the insights. And this brings quite a bit of an advantage over the traditional service mesh idea, because you should have, in my opinion, way less nodes than you would have pods. If this is any different in your environment, we got to talk. Yeah, this is the approach that they are taking. This is basically the UI of that. I can quickly also jump into this one. So I built two different clusters, one with Istio, one with Cilium. I've made an attempt before to put them all into one. For the most things, it worked, but in the end, at some stage, they messed up my Prometheus and Grafana instance, which was shared, and then things didn't go well. So for this demo, I separated it. So, no, I didn't want to say it's a pet clinic. What I wanted to show is here the Hubble UI. So the Hubble UI is to Cilium is basically what Kiali is to Istio. This is your web UI. And here you can see all the namespaces. So these are the same namespaces as we had before, of course. So yeah, this is the namespace where the distroless application runs. There is not much happening because there's only one container. Okay, so it was not the best demo idea. So go back to that one. Let's, for example, take the OpenTelemetry one. And now you're going to get this kind of graph right out of the box to see. And if you don't believe me, what I wanted to show here. So if we go back to k9s, and what's that? Oh, I'm still in the container. So k9s. And you can see here I'm now on this Cilium cluster. And if I go, and if I look here at the OpenTelemetry namespace, every pod has like one of one. That means like there's one container in that pod. So if I switch the namespace, added the context to the other cluster, and I have pretty similar things installed there. Now you can see they're all like, where did it go? 2 of 2. And if I go into one, then you can see there is the actual application component, which is a Redis in this case, but there is also the Istio proxy. So this is like your sidecar that queries all the things. And this is the stuff that you don't have if you take that eBPF approach. So this is, yeah, it hasn't been around for a long time, but I've just been to KubeCon about 3 weeks ago or so, and there was certainly a lot of hype and buzz around that technology, and in particular, Cilium as a project. So I really like the idea that this kind of sidecar-based service mesh is getting a serious alternative here. And for us, we will have to wait and see where the directions of things go. But certainly, this is also something I would definitely recommend everyone to try out, because you only install it once, and then all your various namespaces, no matter what they do, you would get a graph. And so this is, again, the Spring Pet Clinic, things coming in from API gateway to the various services and so on. We don't see connections here right at the moment. That's just because there is no traffic flowing. But also, if you, for example, go on an internal namespace, like the Kubernetes system, then you would see all the components which are installed there. This is the headlamp component that we've seen before, and so on. So it's pretty good for getting an initial insights if all my components are there and if they are actually connected and talking to each other. All right. Good. So summary of that. Here you inject the proxy component on the node instead of the pod level. That's kind of the key difference. And leverage this Linux functionality or low-level functionality for observing Kubernetes traffic. As you say, it's early stage of development, even though they are moving pretty fast. So I've seen that Cilium is all now available from major cloud providers. So if you get your Amazon, your AKS or EKS clusters, you can check a box and say, I want this with Cilium. So it's going to be rolled out with that things on the nodes already, which can be pretty helpful in the end. So yeah, right at the moment, eBPF and Cilium pretty much go hand in hand, but there's a lot of other companies that are like putting efforts into this technology as well. So we will see what it will come up with in the future. All right, so now we've done a couple of things. So from an API server, we saw on a high level if actually things are good or bad, a few high-level metrics. With the various types of service meshes, we were able to isolate poor performing components and see basically where in a certain area things would go wrong. But still, that doesn't leave us with the point, how are we going to find failures within an application? So on the application-based side of things, of course, if you want to know something about the application, you somehow have to get into that application and query metrics from inside of it. In the end, it will be in a way that you like observe the metrics, you put them into a database, you visualize them, and then you can see it for reporting. I'm not sure who has just been to the talk of Dotan Horowitz? Nobody. Okay, you've been there. You've been the speaker, right? He told exactly about this, those things in that flow. Yeah, as you all haven't seen it, please watch the recording. It was a great talk. Now, if you want to do that, or if you want to go application-based monitoring, you will certainly find out you have many different options to do so. I've just outlined a couple of them here. And this is also a bit of what was kind of the problem with application level or distributed tracing in the past, that different companies and different projects kind of did their own thing. And so the observed metrics were not like the same, and it was kind of difficult for them like to correlate. So you had to bet on one thing, and then you missed features in the others, and so on. So this is what OpenTelemetry is kind of trying to change. And I've added this diagram in here. I mean, you don't need to understand all of the things in here, but the key difference that it makes, it tries to standardize the let's say the implementation or the format of the observed metrics into like a standard which is the same for all participating parties. So you can query those metrics from various agents, you can query it from Kubernetes itself, from infrastructure, and so on. And there's this OpenTelemetry collector, which they would all route their information into. And this one would basically be able to understand all the metrics and so on. And all this part will be open source. Then on the right-hand side, you can process those metrics and send it into databases and evaluate that. And that's basically then where the vendor solutions come in. So the vendor solutions in the future, at least that's what I hope, will basically compete on the right side of things. So what they do with the metrics, how they visualize them, or how they predict things with it whatsoever. But from a pure monitoring perspective, this one is kind of trying to attempt standardizing on the querying or the collecting side of the metrics, which I think is a pretty cool thing. Yeah, and you've seen before that this CNCF landscape is fairly distributed, so to say. I like the approach this one is kind of taking, where you can see, okay, a couple of open source projects are now coming together into one, and things like standards for a certain topic evolve there. Now, how does this work? How am I going to get some observability into my application? There are actually various ways. I mean, the least intrusive one, where I would say, well, this doesn't kind of require a rebuild of the code, is adding the agent into the container. So this one would basically download the agent, and then when you do the command and start your Java application, you basically attach the agent to the Java process, And then you need some configuration in your application, of course, to say this is where I want to send those metrics to. This is, in this form, least intrusive because you don't have to rebuild your jar file or your code. But it's still, you have to rebuild and repackage your container and have to do some changes in the application information. So this is like the configuration then, where I say, okay, this is the name of my application. This is the endpoint of Jaeger, and where I want to import the things to. So this is one example. Another one would basically be to really go into the code of your application. So, and even there you have various options. So here on the Java side, there's, for example, from the Spring Cloud framework, the sleuth agent that you can use to query information. There's also a generic one from OpenTelemetry itself. And there you can see this is kind of the good thing. Even though there are different agents, they will all in the end come together on the same metrics level, which makes it easier for people to say, okay, I want to use that agent now, or I'm going to replace it later with another one. That would absolutely work absolutely well because you don't change your overall observability infrastructure. And again, the different agents will have different configurations. In the end, what they will all need is that kind of collector endpoint. This is basically where all the metrics going to get together then, and they can be processed from that further on. All right, so I was talking about Spring Boot before, so now there's Quarkus, there's many other frameworks. Most of them have their own implementation, but as I said, you can also use the generic Java one. So I'm not going to read through all this. All right, so this is Jaeger, which is like a distributed tracing framework and has some nice visualization to it. And with this one, shows pretty well where the differences in this observability level is. So here we have like a call to this demo application called to do UI, which will then call another application which is called to do backend. Those metrics have just been collected by Istio, and that's why you don't see any details in there. So you basically only see what is the overall time frame from the overall call and what is the time frame of that span, but you don't see into the application. So this one is the same call, but being done with an OpenTelemetry agent implemented. And now you suddenly start seeing things within the application. So it's the same surrounding call, like the get call, but these are like methods in the application now. And if you have any kind of poor performing method or whatsoever, you will basically be easy to visualize and see that here. And you can go even further. So this is a piece of Kotlin code. You're not supposed to I mean, of course, I would be happy if you understand it, but I don't. It's not mine. And the thing is, I said before, with the default instrumentation, you kind of get default monitoring. But what if you have a certain method in your environment that you want to particularly enable for monitoring, or if you want to have a certain field that you want to monitor at a time. So for example, if you have a poor performing request in the web shop, it's of course nice if you find out what that poor performing method is. But it might be even more interesting if you know what are actually the items which are being processed when this slow kind of call is actually happening. So you can see those two things here. So with this with-span annotation, I'm going to add this product handler fetch and say, okay, this is like a new span that I'm going to see in my workflow or in my trace. And this span attribute ID is something which I also add to those metrics that I'm going to collect. So this is the Jaeger output of that, where you can see like above, this is like the overall trace. But maybe I can, yeah, I did it. So here's like there's this custom span that I created, which would have not been picked up by the standard implementation. So I can clearly cut it down to this one now and say, okay, I will figure out how this works over time. And if I expand it, I also get this ID that I collected. I mean, in this case, it's just an integer, so it's not so important. But anyway, there's just the fact that you can customize which are the things that I would actually want to monitor. I think is pretty cool. So this is kind of the deepest level that you can go. On the other hand, of course, it also means this is like the deepest level of intrusion, because you need to change the code in order to get that. So it's not only the configuration and the rebuilding. With this one, you actually have to change that code. I'll try to show that live. This is just, I don't know if you know that those two persons. Nicholas is actually the one who has written that demo where I just showed those snippets from, which was pretty helpful for me. So this is the GitHub link to that sample. I'm going to share a link to the slides later on anyway, so you can look it up from there. So what is the time? Say 5 minutes. Yeah, I maybe be able to show some more. So going back to Jaeger. So with this one, I'm now monitoring the OpenTelemetry demo environment. And for example, I'm going to this add service now. And this one will say, OK, I have 2 traces and 2 spans. Now, if I expand that and say I'm going to go in there, what are the tags? What is the process? I can see here that the collector of this matrix is actually Istio. So this is basically coming from my service mesh. It doesn't have any insights of the application level. If I change that and change to another Jaeger, I mean, this is not a setup that you should repeat. This is just a demo setup where I put multiple different things in there. And if I do the same, no, this is not the right one. Okay. Yeah, so if I make wrong bookmarks, it's not going to be very helpful. So I don't have any traces in here. OK, I can't show you that now, so this part doesn't work. Sorry for that. I have anyone. So they went to sleep. The good thing is you can also try out those things if you don't have Kubernetes, because you can certainly set up an infrastructure where you have the application, the monitoring agent, the collector, and then Jaeger for visualizing the data. There are quite a few projects around that you can just like spin up by yourself. You only basically need Docker to do that then. So I'm trying to do it. This is the one that I was talking about before, where I put that span and things in there. So let's just see if I can get this. Yeah, it's responding really slow now. And this is not my machine, so it's running in the internet. So I'm spinning up basically 2 components to do that. So this is fine. So I'm going to make this public. I have this. So this is just basically running in Gitpod. I'm not sure if you're familiar with that. That's like a development environment kind of in the cloud. So you have your own development environment here where you can run containers inside. So, and you get an endpoint. So I just started that. Right now, I don't have anything in there. Now, if I change the terminal and say, so I'm going to do a call called localhost 9080 products, I think was the name. Then this is going to go through here. If I refresh that, I should hopefully get some metrics now. Yeah, I have them in here. So now I got that trace. It says 26 spans. So this is the one that we saw before. And yeah, if I go into that one, I can basically now see on the process, this is like using the OpenTelemetry SDK for querying all those things. So this is running inside of my code. And then I can do the drill down and get all the information from that. So yeah, just looking into the code, there is the dependency that you would have to add right here for that instrumentation. And then add some configuration to basically say, this is what my application will look like. And then the forwarding and the configuration of the app is basically done here. So this is where you configure your OpenTelemetry collector and get the things to work. So yeah, I just can recommend for everyone play around with it a little, get familiar with it. It's actually pretty cool. Yeah, and I think I need to come to an end. It says 1 minute. Okay. Yeah, I have to skip that. I hope I could give you a bit of an insight of what the various options are, depending on what kind of level of the metrics you're going to get. This is probably going to change quite still a lot in the future. I mean, one of the things which would actually combine some of the things that I talked about here is, from what I heard, is people trying to use eBPF to live inject an OpenTelemetry into an application. So that would mean you don't have to like rebuild the code or rebuild the container, which would be actually pretty nice. I'm not sure if this is technically possible yet, but yeah, we can only benefit from all this development. And yeah, so with that, I would want to say thanks in the first place, and yeah, open this round for questions.